Okay, so here we are on my computer screen, and I want to show you how to work this with Desmos. So if I've been to Desmos recently, so I actually have an icon there, but if you will just type Desmos in your search engine, you will find yourself landing here, the very first one, and right here it says Launch Calculator. So I'm going to click that. And now I'm on the free graphing calculator, and I could do anything I want right now, but I want to show you how to make a graph that you can save and use for later. And so if you forget any of this, I just want to remind you that right up in here is a help center that I've found really wonderful. I've been able to figure out just about everything that I need on Desmos just with this help center. And how I remembered to do this was I went to my help center right here, and I wanted to be able to save a graph to Google Drive. Now this saves the image of a graph. If you save that, you'll have a graph that is not interactive. It's just a picture of it. But if you want a graph that you can work, add to, change the size on, move around on, you want to save your graph. I chose to save it to Google Docs, and that seems to be the one that works the best for me. So you want to save that, and when you click this, it'll tell you exactly how to do that. But I'm going to show you that now. I just wanted to show you that that is the help center and how it can work for you. So the first thing I want to do is to show you how to make a graph. So I'm just going to type in an equation. I might type in x plus 2. Sorry, I got x equal to, I forgot to shift, x plus 2. And I used my keyboard, but I could have pointed to these down here and that would have worked fine. I just realized I forgot y equals. And so I'm going to go back here and I'm going to add in y equals. I could be typing this with my keyboard, but I'm just showing you that I could also use this entry pad there. And so now I have this graph. Now, if this was all I wanted and I wanted to be able to save this graph, then I go right up here to this untitled graph. And there's two different ways you can save. You can just save it on this page, but if you're going to make a graph the night before that you want to use later, then to save it, you might want to save it into your Google Docs. So I'm going to click, and it gives me an option to sign in. If you don't have an account, you would make an account. And if I use this lower one using my email address and sign in, then it will not save to my Google Drive. So I'm going to do this. You have to be signed into your Google Drive on Google, and I'll just link using the Google Drive, and I'm going to choose this account right here. I have more than one. I have one with my CUSD, but the one that's Clovis USD.K12, all that stuff, that is the one that gets you to the curriculum guides, and so that's where I'm going to have this saved, is in there. When I want to save this graph, then I'm going to check send a copy to Google Drive, and I will save this as practice graph. And now I'm going to go ahead and save it. And it's saved. It's saved in a couple places, I believe. Let me see if I'm right. Yes, it's saved right here. I clicked these three bars. It's saved right here. If I decided I didn't want it, I made an earlier one. I don't want that earlier one. I can just click that X and it'll go away. It gives me a sec to undo that in case I want to change my mind, but notice that that's gone now. And there's this other practice graph here too. There are some graphs that are built in. So there's only two with X's here, ones that I've made. These ones are built in by Desmos and things you could use to demo. So now I want to show you where that graph went that I saved. So I'm going to go to my Google Drive. Oops, sorry, let me just show you what the whole drive looks like. I made a folder called Desmos Graphs. When I look in there, I'm not going to see the one I just saved because it always just saves to the bottom, not into any particular folder. So I'm going to go ahead and move this into my Desmos Graphs folder. There it is. And then I'm going to open that Desmos Graphs folder, and I see my practice graph that I just made. And what I'll get is a link to that web page. So actually, if I close the web page I was on a minute ago, it's gone. When I use this link, it'll open a new web page and it'll give me that. If I hadn't closed it, I would see two of the exact same thing. And I'm back to this graph. And so this is a great way you can use this to preset things up. Now I've preset up already the entire lesson. So I'm going to go back to my Google Drive and I want to close this one that I didn't really want to be in. This is the one I want to show you today and how that can work. So I'm going to use that. There's a link. It'll open another page up here. Notice. And now I have all of the equations typed in for that entire polynomial in behavior exploration. So the first three that we just did earlier are right here. We just did those on the graphing calculator, and I can see those. If I want to resize this screen, zoom in or zoom out, these plus keys will do that. Now I might need to slide the graph up to be able to see what I want to see. Because I have a yoga, so I have a touch screen. I actually, right now, I'm going to pinch this screen, and I can do just like you would on your smartphone and make things bigger or smaller by touch. But if you don't have that, then what you're going to be using is these plus and minus keys to get those in. And those are the first 3 graphs that we compared using the graphing calculator. I like that they're in color. If you're going to be projecting this, instead of having the kids do it, then over here in graph settings, see this tool that I'm at? I'm going to click this, and I'm going to click projector mode, and it just makes everything a little darker so it stands up better. It's also a place where you can set to a specific window if you would like. And there's some other things you can do. I want to get out of that now. Go away. Good. And so those are the first 3. So the next question on that, I'm going to turn these 3 off. And the next question asked us to graph 3 equations that had negative signs, but they still had even exponents. And I can't quite see that. Let me slide that up. And I can see that they're pretty much the same graph, but now they are all starting low and ending low. So that's what happened with that negative sign. That's what we would have predicted from our earlier chapter's work. So number 3 asked to contrast and compare the graphs of the function in problem 1 and 2. And so I would talk about when we had a positive leading coefficient and an even exponent, they started high and ended high. When we had a negative leading coefficient and an even exponent, they started low and ended low. Something like that. They might notice other things. It'd be interesting. So when you've finished answering question number 3, giving them time to write about that, asking them what they came up with. The next one, problem 4, gives us the next 3 equations with odd exponents. And so you might ask the students to predict before you reveal these, but these are the next 3 that they asked them to write. I'm going to move this down, and I'm going to zoom in just a tiny bit. So notice I have a pretty zoomed in graph. I'm just at -4 or 4 and -4. And these are 3 odd functions with positive lead coefficients. They start low and end high. And that would be number 4. They would have to draw those down really quick if you want to show them one at a time. There's the first one, the x to the 3rd. And then here's the x to the 5th. And then here's the x to the 7th. So it's your choice how you like to model those. And then on number 5, it goes on to the odd exponents. And they should see that these graphs are the same graph, but reflected across the x-axis, which is what they learn negative signs do in function shifts. And so these odd functions are starting high and ending low. And so 4, 5, and 6, we just talked about that. Notice you would be giving your students time to write and draw, but it goes really quickly, this exploration as a demo with things pre-typed in. It's a lot slower when you give the kids time to type things in themselves, but it's good experience for them with the calculator and the typing and things like that. So 7, 8, 9, those problems aren't necessary for the kids to get to. So judge your time accordingly if you have time. Students might just wonder what happens when there are extra terms, because so far we've done all monomials. And so those problems are there for that question. But we've got what we need for the lesson now. So what you'll see is with these 2 terms, we now have something that was even. It still started high and ended high. So the lead, the degree of the highest term is the one that was making the decision. This one does cross the x-axis and come back, where all the other evens, like the monomials, they were all in the positive. So this little piece of subtraction is making the graph a little bit lower. It's also shifted with the vertex not right on the y-axis. And so there's lots of things we can talk about later. What we'll really be finding out later is about the x-intercepts, but they probably are not going to notice anything about that now. If we add another graph, this x to the 4th has some interesting stuff going on, and here's a more wild and crazy x to the 4th. I think I want to make that bigger so they can see better, and I'll turn off this squared. So these are both x to the 4ths with an extra term. It's a binomial, and so they don't all look just like a perfect W. Some of them are kind of asymmetrical. And so it gives them a chance to explore. When we throw the negative in there, notice these were all even exponents. They all still started high and ended high. And when we throw in a negative exponent, let me turn off the positive a negative lead coefficient. Turn off those pauses. We still see them all starting low and ending low. But again, more wiggling around, not just with vertices on the y-axis. And then if they go on and check out the odd lead coefficients, the odd degree, pardon me, where are we at? There we go. There's odd degree. This one has a positive lead coefficient, odd degree, starts low and high. This one has a positive lead coefficient, odd degree, started low. I need to make this bigger so I can see the whole thing. I'm sorry, make it smaller so I can see the whole thing. There you go. Started low, came up, had a maximum, came down, and then back up, ended high. And then this one with a negative, you might have them predict, and hopefully they'll predict that this will start high and end low. And in fact, it did. And so you can work your way through this exploration relatively quickly with a little pre-preparation. And then because I saved that to my Google Doc, that document will be there for me next year when I want to teach this again, or next period when I want to teach it again. And all I have to do is turn off the graphs and have a clean slate and be able to start again for third period or whenever your next class is. So all that work is very nicely done.